Bismillah ar-Rahman ar-Rahim. In this video, I'm going to talk about definition of the group with some examples. First, G, the CSG with binary operation is a group if satisfied the four conditions. The first one, the closure property. For all A, B in G, A star B in G. Second one, associativity. ABC for all ABC in G, A star B star C equals A star B star C. Identity, there exists an element E in G such that A star E is the same E star A, which is equal to A always. And the inverse property, for each element in G, there is inverse of A, such that A star A inverse is equal to B. And the group is called abelian commutative if A star B equal to B star A. Example number one. The set of all real numbers. The set of all real numbers with addition, the binary operation addition. So, property number one. See, for all real numbers A, B, and G, clear the sum of two real numbers is real number. The sum of any two numbers is real number. Clear. The first one exists. Number two. A plus B plus C is same as A plus B plus C. This is clear also for all A, B, C, and R. Like, for example, if I said 2 plus 5, 7, plus 4, 11. So this one, 11. Then if I said here 5 plus 4, which is 9, plus 2, 11. So this is 11, and this one is it. Positive or negative for all A, B, C, and R is the same. Then, and the third one, identity. A clear 0 in R. 0 in R. So we have 0 plus any real number is the same real number. Like I said, 0 plus 5 equal to 5. 0 plus negative 2 is negative 2. 0 plus 0 is 0. 0 plus 1 is 1, and so on. So 0 plus A. So there is an element which is 0. A clear 0 is an identity. Now, inverse. If I have 5 plus what will be equal to 0. So clear negative 5. 0 plus negative 5 is 0. So we have 5 plus the inverse of 5. What inverse of 5? Negative 5. So if I have A, what is the inverse? Negative A. In R, negative A, which is equal to what? 0, the identity. So if I say 7, what the inverse? Negative 7. So which is equal to what? Identity. Now, if we say, for example, negative half, what is the inverse? Is equal to half, which is equal to what? To 0, the identity, because 0 in the identity. Now, so G is a group now. Satisfy 1, 2, 3, 4, a group. And clear A plus B is the same, B plus A. And I mean 2 plus 4, which is 6, the same 4 plus 2, 6. This for all real number, not only 4 and 2. That is mean now we have R with the addition represent a group, because satisfy the four conditions, the four properties with the commutative property. In really abelian group, commutative group. See, if we said R with subtraction, now this is not a group. Why not a group? The first condition, closure property, is satisfied because A minus B, really real number. This one, the real number. But what about the second property, associative property? Yani mean, if I said A minus B minus C is equal to A minus B minus C, no. Example, say 5 minus 1, for example, which is 4, minus a 3. So I have 4 minus the 3 is equal to 1. But now here, if I said 1 minus the 3, because I have what the B 1, and the C is a 3. And what is the A? The A is 5. Now, 1 minus the 3 is negative 2. And 5 minus the 2, 7. So 1 is not equal to 7. So the second property, the associative property, the second one not satisfy. So this one, that is mean R, so that is mean R with subtraction, this one, not a group. So the same, if I said the set of all integers with the subtraction, the same also not a group. The second property, associated property, is not satisfied. This one. Okay, now the real number with multiplication. This one also not a group. Why not a group? See, we have the identity. The identity is one. Okay, before identity, if we multiply any two real number, clear real number for all A, B, and R, for all A, B, and R, and clear A times B times C is the same as A times B times C. This one also is the same for all ABC, for all A, B, C, and R, and R. But what about uh, the identity? Identity one. We have one identity. This is in R. And for all A in R, for all any element, any real number, A times 1 is A, the same, like 5 times 1, 5, 7 times 1, 7, half times 1, half. So the identity is 1. But inverse, what about the inverse? Yani if I said 5, what is the inverse? 1 over 5 equal to 1. But, see, what about 0? 0 times what equal to 1? 0. So 0 has no inverse. So 0 has no inverse. See, why? Because look at here. We said for each A, and 0 real number. For each A, yes, 5, 1 over 5, 2, 1 over 2, half 2, which is equal to 1, multiplication. But what about 0? 0 is a real number. So what the inverse? 0 has no inverse, multiplication. Because 0 times what will be 1? 1 is the identity. See again, 0 times, return back here. See, 0 times what will be 1? No number, multiplied by 0 equal to 1. So that is mean R with multiplication, not a group. Why not a group? Because here 0 has no inverse, multiplication. If we said, see in this example, if I said R except 0 with multiplication, yes, it's a group. Why? Because now each element has an inverse and there is no 0 here. So this one, yes, it is a group. And this group is commutative abelian. Why? Because AB is equal to B. Okay, now another example. See, another this one, another example. Let us to say R the set of all positive real numbers with multiplication. Okay, with a star. Okay, that is a star. And we have here for all A, B, NR, AB, NR. We just have to define the binary operation A star B equal to AB. So AB are positive real number, positive real number. Number one, for number one. A, B are positive real number. What about now A star B? What we said, the definition, 2 times A positive, B positive. So now this one is positive. So that is mean 2AB positive real number, because A positive, B positive times 2. That is mean the first property, A star B in positive. Number one. Number two. Now, A star AB, now that's number 2, AB star C. Okay, equal what equal? Equal now this one is, first one A star B is 2AB, 2A. Star C, now equal what? Equal 2 times the first one is 2AB multiplied by C. So that's mean equal to what now? 4ABC. This is one, the left side. The second down. A star B star C equal to A star we have BC, it is 2BC, 2BC. Now A star 2BC equal what? Equal 2 times, what times the first one? A multiplied by what? 2BC. Now we have the multiplication, 2 by 2 is 4. A, B, C, so which is equal to this one. So that is mean A star B star C equal to A star B star C. So the associate probability also satisfied. No problem. Now, identity. Now, A, B are positive real number. So now A star uh, B equal to A. What is the B? There is B. There is B a real number such that, which is called identity. And let us write this real number. Let me write it E. Okay. So now the question is, there is E if A a positive real number. If A, see, if A is a positive real number. So the question is, there is E. uh, there is E such that A star is equal to A and E star A is equal to A. Now see number one, A star E equal to A. Yes, there is. See, A star E, let us say equal to what? To A. So now what is A star B? It is 2A E equal to what? Equal to A positive real number. Okay, A is positive real number. So then positive real number, what I have? I have 2E is equal to 1. What about E? See, now what about E? The 1 over 2. 1 over 2 is positive real number. Now, we have, now, if you have A, C, star, what now? The identity half equal what? Equal to C. Equal 2 times the definition. This is A and this is B. A to A, B to A, B, which is equal to what? C, a clear, which is equal to A. So now the identity is half. So we have now for each element in R positive real number, half in identity, of the identity. Now, the inverse, what about inverse? If A, now, if I said, now, A positive real number. Now, what is the A inverse? Such that we have, okay, so that A star, A inverse equal to what? The identity. What is the identity? The identity, we said half equal to, okay, now, that's it for the inverse. Now, A times A inverse, which is 2A, A inverse, this A, this is B, 2AB, okay, which is equal to what? Equal to. Now, what the A inverse is equal 1 over divided by 2A because A is positive real number. So 1 over 4A. So now what the inverse of A? 1 over 4. Check now. Now this is A. The inverse is A inverse equal what? See, A, the inverse is 1 over 4A. So equal to the definition. This is A star B. So the definition A star B is 2. First one, A, B. The B is 1 over 4A. Okay, so equal to. So what you have? A with A out, with positive real number cancel, and 2 times 1 over 4 is 1 over 2, which is what? The identity. We said the identity is 1 over 2. So that is mean we have R positive. With this operation, what the operation is A, B equal to AB is a group. This one, a group. And really this group, this one, abelian group commutative. Why? Because for each AB in R positive real number, we said here A star B to AB is the same B star A, which is 2BA, because AB, BA are the same. That is mean for all A, B, A star B equal to B star A. So commutative. So A positive real number with this operation is commutative a group. Is commutative a group.